Okay, folks, this is it. I have posted a bunch of videos today. I think this is the last one. I think this is it. So, question number 2, 15-minute question. I broke this up. The answer keys I'm going to give you are going to be slightly varied because I made a couple variations and I split them up into A, B, C, whatever. So when I give you the answer key, don't get thrown too off that the answers don't seem to match up exactly to their A, B, C, or D counterparts. Okay, part A though was the same. Using appropriate units, explain the meaning of the absolute value of the velocity function from 30 to 60, and that means we're talking about distance. Okay, not displacement. We're talking about total distance traveled. Okay. Part B, approximate, and this one I changed on you. Approximate the integral from 0 to 60 of the absolute value of velocity using midpoint approximation with 3 subintervals. The reason I did this is because I think it's a confusing concept with the table of values. So 7 values using midpoint estimation means I'm going to use the 2nd, the 4th, and the 6th, okay? And this is what it comes out to a number. So let's look at the table first. So first things first, here's our table of values. And we're looking at midpoint with 3 subintervals. So we do this. 1, and then we include that 2, and then we include that 3. So here are 3 subintervals. Okay? Those 3 values. And specifically speaking for us, we're not using the acceleration, we're just using velocity. Okay? So our subintervals now, notice that's our delta x. So in that case, that's 25. This is our delta x, the 2 numbers on the outside. In that case, is 30. This is our delta x. In that case, is 25 again. So it's really important to know that using that 25 formula. That being said, our first delta x, or in this case, delta t, is 25. That's 25 minus 0. Our second delta t, which says 10, was 35 minus 25. And our third delta t was 25, 60 minus 35. Our values that we're looking at are our v of t values. So v of 15, right here, is 30. Remember, we're talking absolute value. V of 30 here is 14. Okay, that's my v of 30. And 0 is my v of 50. Okay? So that is my midpoint approximation. These are 3 rectangles, 25 times 30, 10 times 14, and 25 times 0. Adding them all up, I get 890 feet. That is our approximation using midpoint formula of distance traveled on that 60-second span. Okay, part C says using appropriate units, explain the meaning of, and notice this is the integral from 0 to 30 of acceleration. This is acceleration. So in this case, in this case, this is the change in the car's velocity. The integral of velocity is the change in position, but the integral of acceleration is the change in velocity in feet per second. So if we're talking about something changing, in this case, there's always going to be a per, and if we're talking about velocity changing, we're talking about feet per second, from 0 to 30 seconds. Okay, so again, this is the integral of acceleration, which means it's the change in velocity. All right. Down here, okay, part D, find the exact value. So this is going to be something they're going to ask, I guarantee, in some way, shape, or form. They give us this to find the exact value. We need to understand that the acceleration is in fact v prime, and we need to understand the integral of v prime is v. So when I integrate this, I get v of t minus v of t, and then evaluating at 30 at 0, I get v of 30 minus v of 0. Don't go this far and screw up your negatives. Negative 14 minus negative 20, or 6 feet per second. Okay, last 2 problems. Let's go. Okay, I made a mistake here that I hope you don't make. So part E is, for 0 to 60, must there be a time when v of t is equal to negative 5? So I spent all this time, 0 here, and v of t is negative 5, and then I put v of 35 is negative 10, which is totally less than negative 5, so, it's down here. And v of 50 is 0, which is above negative 5, which means if I'm connecting these 2 points, they have to cross over negative 5. All right? That's what this is talking about. Okay? So this is 0, this is negative 10, this is negative 5. At some point, it has to cross over negative 5. But, and then I said, because it is continuous function, by the intermediate value theorem, there is guaranteed to be a value on it on the interval where v of t is equal to negative 5. But I guess I answered the question. I guess I'd get full credit. But I never did say yes. So I think it's important to say yes in these cases. Okay, last one. Once again, yes, this is true. And it looks for the acceleration equal to 0. The only time we can say this is true is if we know there's a velocity that both equal the same thing. And if that's the case, then we know we have Rolle's theorem. In this case, we use mean values theorem, but Rolle's theorem is a specific case of mean values theorem. So mean value theorem talks about the slope of that line. There will be a repeat like that in that interval. Rolle's theorem, we don't have to specify it. Mean value theorem is perfectly acceptable. Rolle's theorem is a special case of the mean value theorem where the 2 y values are the same, therefore my slope is 0, therefore I am guaranteed a max or a min or a 0 slope in between there at this point. So I don't need to use the term Rolle's theorem, but this is really Rolle's theorem. And when it says the acceleration is equal to 0, I'm looking for 2 v's that are the same. Well, there are my 2 v's that are the same. V of 0, which is negative 20, and v of 25, which is negative 20. Therefore, somewhere between 0 and 25, there will be an acceleration, which is really v prime, that equals 0 by the mean value theorem. And once again, so yes, folks, I think that's it. So excited for tomorrow. I'm going to post this right now, and I will open myself up to questions and comments and emails by you guys in the next 24 hours, and we'll get this done. Very excited for you. I know you're going to kill it. Let's go.